So we're talking about different types of data. So it's important to note that all data, all collection of objects or people or letters or numbers is called a set. So there are two different types of sets. There are discrete sets, which are made up of isolated points and can be written as a list. A discrete set contains very specific numbers, like it could contain the numbers 1, 2, 3, 4, and 5. It could contain all the even numbers, but it contains numbers that we can actually write out. Now, it is interesting, the discrete set can be finite, which means it can be countable, or it can be infinite. So a discrete set could go on forever and ever and ever and ever and ever, but it could still be discrete. So the other option is that it's a continuous set. And continuous sets cover a range of points, including those between isolated points, and cannot be written as a list. So what continuous means, like something that would be continuous would be all the numbers between 1 and 2. If you think about every number that's between 1 and 2, well, there's obviously 1.1, but then there's 1.01, and 1.001, and 1.0001, and 1.000001, and you can continue with that forever and ever and ever, and there's no way for you to write out all of the numbers between 1 and 2 because there's so many of them, and so that's why they're called continuous. Now, the way those sets are labeled, discrete and continuous, is very interesting. So when we label a discrete set, we use what's called the fancy brackets. And the fancy brackets look like S-shaped brackets, which is why I rewrote the word discrete using a fancy bracket. Continuous functions use one of two things. They either use a parentheses or a bracket. But either way, you can imagine the word continuous being written using one of those two things. So the brackets and the parentheses matter. When you use parentheses around a continuous notation, what that means is that the first value, if you use parentheses at both ends, it means the first value and the last value are not included in the set. So if I were to write the set 1, 2 in parentheses, what I'm saying is that I want all the numbers between 1 and 2, but not 1 and not 2. If I use brackets, however, what that means is that the first value and the last value are included. So brackets mean they are included and parentheses means they're not. So if I rewrote the set as 1 and 2 in brackets, that means every number between 1 and 2 and 1 and 2. So that's the only difference between them. Well, sometimes you can have brackets and parentheses. So in this case, I've got a bracket at the beginning and a parentheses at the end. So that means the first value is included in the set, but the second value is not. So if I were to use the set again, 1, 2, with brackets then parentheses, that means every number between 1 and 2 and the number 1. And then the last one. This one, since it's a parentheses at the beginning, that means the first value is not included. And since it's a bracket at the end, that means the last value is included. So if I were to have the set 1, 2, with 2 being in a bracket, that means this set contains all of the numbers between 1 and 2, and it contains 2. So we're supposed to decide if these sets here are discrete and finite, discrete and infinite, or continuous. Okay, when they are continuous, remember continuous is going to use our parentheses or our bracket, because either way we can write the word continuous with those. So looking at these sets, well, the first one's not, the second one, 0, 6 is, the third one's not, the fourth one's not, the fifth one is, so -9 to -12. So those would be my continuous sets. So our discrete sets, recall that we can write discrete with our fancy brackets. So we have two options. We have finite and infinite. If it's infinite, what that means is you're going to see dot, dot, dot in there somewhere. That's what infinite means. It's going to have dot, dot, dot because it keeps going. So this first one is discrete and infinite because it's telling us that it goes on forever and ever and ever. It's all the integers, 1, 2, 3, 4, and it's telling us to continue that. The second one, we already said was continuous. We've used that. The third one, 7, 9. Well, it's in the fancy brackets. We can count how many terms there are. There's 2, so that makes it finite. The third one would also be finite because we can count how many terms there are, and there's 4 of those. And the last one, because it has the dot, dot, dot in there, that means it's discrete and continuous. So it goes from -6 to -4 to -2. I forgot my dot, dot, dots at the beginning. So in a mapping, mappings are ways that we write ordered pairs. The domain is the set of all the values used on the left-hand side. In an ordered pair set notation, the domain is the set of all the x's contained in the ordered pairs. So if this question asks us for the domain of f of x, well, my domain, it tells us on the left-hand side, it's all of my x's, so it would be 3, 5, and 7. Now, this set of data, we have to decide if it's continuous or if it's discrete. So the question is, does it just include 3, 5, and 7, or does it include everything in between? Well, the only numbers listed are 3, 5, and 7, so it's just those. That makes it discrete. So it's going to have the fancy brackets. The next question says, what is the domain of g of x? Well, recall that in an ordered pair, it's always an x and then a y, and our domain is our x's, so that means that we're ignoring the second numbers. I'm actually going to mark them out. And our domain would just be the numbers listed in the x position. We do not have to write them twice, even if they show up twice. We only have to write it once. So my numbers are -5, -2, -1, and 0. And again, we've got to decide, is it discrete or continuous? Well, there's only 4 points, so that makes it discrete, so we use our fancy brackets. So in a mapping, the range is the set of all values used on the right-hand side. In an ordered pair notation, the range is the set of all the y's. So my domain is my x's, my range is my y's. So they're asking us for on the next page, they're going to ask us for the range of this function. So my range would be 6, 8, 10, and 11. And it is going to be a discrete set because it's just those numbers. So the next question is, what's the range of g of x? So if it's my range, I'm just worried about my y's, so I'm going to cover up my x's. And again, I don't have to duplicate numbers, so if I look, it says 7, 8, 8, 8, 7, so really my range is just 7 and 8, and that is countable. It's finite, so it's discrete. So the next question is talking about the domain and range of any non-horizontal linear function. So what that's saying is, imagine that we have an x and a y axis, and we had a line on that graph. When we're finding our domain and range from a graph, we're trying to figure out where our graph starts and stops. So our domain, we read from left to right. So we're looking for the left side of the graph and the right side of the graph. For our range, we read it from bottom to top. So we're looking for the bottom of the graph and the top of the graph. If you think about a line, lines just go on forever. They never stop going. So for any line that is not horizontal or vertical, so let's specify any diagonal line, the domain is what we would say all real numbers because it goes on forever. Written in interval notation, it goes from negative infinity to positive infinity. And that's true for the range as well. Because that graph of a line never stops going to the left, it never stops going right, it never stops going down, it never stops going up. Now, when we talk about parabolas, they're a little bit different. So we have this function here, y equals x squared plus 1. So again, remember our domain we read from left to right. So first of all, you need to know that for any parabola, for all parabolas, whether they open up or down, our domain is negative infinity to positive infinity. Our range, however, is going to be different. We said our range, earlier a second ago I said that we read our range from the bottom to top. So we've got to find the bottom of the graph. Well, if you look at this graph, the bottom of it is right here. The top of it doesn't actually exist because it goes on forever. So the way we write this is we write that our graph starts at 1, so we're going to put a bracket there, and it goes to positive infinity, so we're going to put a parentheses. The reason we put a parentheses is because we cannot actually touch infinity. And since we can't touch it, we just have to put a parentheses there. The next one asks us for our domain and range. Again, our domain, as we said before, it's a parabola, so its domain is going to be from negative infinity to positive infinity. For my range, I'm reading from the bottom to the top, so I want to find the bottom of my graph. It would be right there. And that value is at negative 5, so it would be bracket negative 5 to infinity. So there's a couple things I want you to write down. They're not necessarily on your notes, but we're going to draw some pictures and talk about some stuff. So your parabolas really open one of two ways. They either open like this, up, or they open down. So depending on which way they open determines our range. So the domain of any parabola is negative infinity to positive infinity. Always. It doesn't matter which direction it opens because that means that the parabola never stops getting wide, which it doesn't. Our range, on the other hand, is a little bit different. We said that we read our range from bottom to top. Well, for this parabola that opens up, it has a bottom value. It has a minimum point. So it's going to have some number, and it's going to go all the way to infinity. And this number that you get here comes from wherever this number is there. Whatever that value is, the horizontal value. If you were to draw a line there, where does it cross the y-axis? But if my parabola opens down, it doesn't have a bottom. It never stops going smaller, but it does have a top. Here. So for a parabola that opens down, our range is going to be from negative infinity to some number. And that number is going to come from this point. So hopefully this will help you just kind of how it's supposed to look. So moving on to the checkup. Number 1 says, which of the following sets are discrete? Well, remember discrete, we can write that using our fancy bracket. So anything with fancy bracket. So that would be the first one, not the second one, but the third and the fourth. Number 3 says, which of the following sets are continuous? Well, continuous we can write with our parentheses or our bracket. Either one we can see as a C. So that would be the second and the third would both be continuous. Number 5 says, what is our domain and range of the discrete and finite function? Well, our domain would be our x's. It tells us it's discrete, so we're going to use our fancy brackets. 4, 5, and 9 would be our domain. Our range would be our y's. That would be 2, 6, 7, 8, and 9. And again, that does need to be in fancy brackets. If you're having trouble making your fancy brackets, by the way, and it's really annoying you, the easiest way to make it is to write a forwards S and a backwards S, and that's how you get them. Number 7, what's the domain and range of the discrete function? Well, my domain is my x's. So that would be -8. Well, I've got 2 of those, so I don't need to write it twice, but then I have -2, 0, and 10. And my range would be 4, 9, 14, 6. Then I've got another 6, but I've already written it, so I don't have to write it again. I'm actually going to do number 10 on this problem. It says using interval notation, what is the domain and range of the continuous function quadratic y equals -2x squared plus 6? So we said earlier, for every single parabola, our domain is going to be -infinity to positive infinity. Our range, however, is going to be a little bit different. So since this opens down, that means it has a top. This top is here at positive 6. So that means my graph starts at -infinity and goes all the way to positive 6. And it's going to have a bracket at positive 6 because it actually touches 6.